Aw, man. Hey, what's wrong? I have this cup of water, but I don't know how many water molecules there are, and I want to count them, but... You know. Yeah. I wish I could solve this extremely common, everyday problem I seem to have all the time lately. Well, as a student of chemistry, I have this problem too. Not in my home life like you have, but at school. Let me help you.
That's a lot of water, and molecules are small. How can you count them? You can't see them at all. I wish there were a unit of a very large size to help me measure what I can't see with my eyes. There is that kind of unit, and it's called a mole. Ooh, tell me more. It sounds really cool. There was this hella rad dude named Avogadro. The mole is a number named after this man, yo. You know how 1 dozen equals 12 of a thing? Yeah, well, a mole is like that too. 1 equals 6.02 times 10 to the 23rd of a thing. 6.02 times 10 to the 23rd? The size of that number seems really absurd. Yes, I'll admit that it's huge, but what else had you expected? It has to be to bring molecules into our perspective. We have the mole, yes, the mole. Thank you, Avogadro. Molecules and atoms make more sense, thanks to this hella rad bro. The mole, yes, the mole. 6.02 times 10 to 23. The mole is a friend to all of chemistry. Wow, that's beautiful, but will you please apply this concept to my water before my cup gets dry? Of course, my friend, you know I'm good and able. Let's get down to work with this periodic table. You see that number beneath the C? Yeah, that's the mass number of carbon, it would seem. Well, what's that number show? Pretty soon you will know. 12.01 grams is carbon's mass in 1 mole. Oh, so 1 mole of oxygen is about 16 grams? That makes so much sense. Thank you, my man. Yeah, man, of course, but let's get something straight. The masses are different, but the number of the atoms is the same. 1 mole of O gives us 16 grams, and 1 mole of C gives us 12. Well, each of these samples has 6.02 times 10 to the 23rd atoms. No matter the size or the shape or the name, the number of atoms in 1 mole stays the same. We have the mole, yes, the mole. Thank you, Avogadro. Molecules and atoms make more sense, thanks to this hella rad bro. The mole, yes, the mole. 6.02 times 10 to 23. The mole is a friend to all of chemistry. Wow, that's great. I can find the mass of O, but water also has H2. Now where does that go? A molecule, yes, the mole works here as well. It doesn't just work for the mass of atoms with it, we can tell the number of molecules of water as long as we know the mass of the dihydrogen monoxide sitting in that glass. Well, I have 150 milliliters, so that's 150 grams. What's the next step for this problem, man? We have to find the mass of 1 mole of H2O. For this, with periodic tables, where we'll have to go. 1 mole of hydrogen is about 1 gram, so 2 moles, of course, will be 2. 1 mole of oxygen is 16 grams. Add it all up and you get 18. 1 mole of water weighs 18 grams. So how many moles are in your cup? 150 grams divided by 18. Let's see, the number of moles is 8.33. 8.33 moles. Now let's try to know the number of molecules. We'll take it slow. 8.33 moles times 6.02 times 10 to the 23rd molecules per mole equals 5.02 times 10 to the 24th molecules of H2O. Got that? Sweet! So there you go, 5.02 times 10 to the 24th water molecules are in your cup, and we were able to figure that out thanks to our friend the mole. We have the mole, yes, the mole. Thank you, Avogadro. Molecules and atoms make more sense, thanks to this hella rad bro. The mole, yes, the mole. 6.02 times 10 to 23. The mole is a friend to all of chemistry. We have the mole, yes, the mole. Thank you, Avogadro. Molecules and atoms make more sense, thanks to this hella rad bro. The mole, yes, the mole. 6.02 times 10 to 23. The mole is a friend to all of chemistry. Yes, the mole is a friend to you and to me.